So this lecture kind of got sprung on me pretty recently. I don't have code prepared, so what we're going to be doing is we're going to be putting a website on the internet today. We're not going to be writing it, we're going to assume that you guys have already written it. How do we get from this code lives on my laptop to my grandmother can check out this cool cooking website I made for her? There are a million ways to do this, and I'm not exaggerating. There's so many ways to do it. What I could do, and one approach that I could do today, which I decided against, is saying, let's follow this exact set of steps, and we don't really understand what's happening, but it'll work every time. And there are a lot of platforms or services on the internet that you can use like that. For example, there's one called Vercel that's extremely popular that I'll probably be using soon for something. Basically, it just takes your React project, makes it easy. You just enter a couple fields, and it just puts it on the internet for you. Easy peasy. Downside is, one, you pay, I think it's like 14 times as much as if you were doing it yourself in terms of your cloud bill. And two, one of the points of this class is to prepare you guys for real-world internships and jobs. Companies aren't using Vercel for the most part unless they're very small startups that just don't have the time to do it the right way. So we're gonna learn about a very modern way of deploying websites today. It's kind of weird. You're not going to learn about this in any other of your classes in this entire degree, I'm pretty sure. Please jump in with questions. It'll make it easier for me. So when we go to, what's up? Nope, nothing. Okay. So when we go to a website, let's go to just GitHub. We type in some address into our URL, a URL into our browser, and it brings us there. So what exactly is happening? How do we get from this particular URL to some server or computer somewhere that has this stuff on it? Where's the jump? So the very first thing that we got to talk about is a domain name. Now, we've always been developing so far on localhost. So localhost or 127.0.0.1 is just our laptop. That's what it means, is just our machine. So that's great if you're just looking at your own stuff. But now we need to get a fixed IP address and actually put some stuff on there. So for example, if you wanted to run a project off of your IP, off of your machine, you need to get a fixed IP address, you need to serve your file, run it like it's a normal project, and you need to buy a domain name, or rent a domain name would be a better way to say it. So we go to GoDaddy or something like that. You guys are all familiar with domain name registrars, more or less. Cool. You buy a domain name. So it could be collinswidgets.com or whatever's cheap, right? So now that that step's out of the way, how do we actually get our code onto a server somewhere? How do we run that code on a server? Well, there's old ways of doing it and there's new ways of doing it. The old way, which is pretty deprecated at this point, is you put all of your code onto the server itself. So like I'll git clone a repo. I'll have some server, maybe it's on Amazon, maybe it's on Google, etc. I'm going to be working with Amazon today. I'm an Amazon boy. Yeah, and then you just try to build the project. Here's the problem. Your machine is different than your machine is different than my machine is different from the Amazon machine. So if I have the last thing you ever want to hear is, this works on my machine, I don't understand why it doesn't work for you. You can't fix that. You know how long it takes to resolve that stuff? It's impossible, literally, in a lot of cases. So the approach of, let's just put the code on a different machine, let's build on this different machine, and fingers crossed, hope for the best, is slow, it's deprecated, it's not a good way to do this. Has anyone in this room heard of Docker? We got 2 people. Good. Has anybody here heard about virtual machines? Probably a couple more, maybe? Okay. So a virtual machine is essentially, this is like the zoomed out 50,000 feet level. It is a computer running on a computer. Well, what's the advantage of that? Well, we can make this computer run the same for everybody. If I'm running a version of, on my Mac, if I have a virtual machine running Linux, and Gordon has a virtual machine running Linux, that Linux that's inside the container will be the exact same environment every single time, 10 times out of 10. So if something works on that Linux, it'll work on Gordon's Linux, because it's the same Linux. That's sort of the idea behind Docker and other containerization techniques. Now, when I call something, or use the phrase containerization, what that means is basically It's essentially a virtual machine. I don't want to go too far into the hypothetical nitty-gritty of why it's different. think of it as its own mini computer running a project for you. And Docker is used by everyone now. I think 70% of the web is run off of something called Kubernetes, which essentially runs Docker. And the rest of it is, for the most part, run off of just Docker itself natively. So let's take a look at what's actually going on here. There's a lot of theory that I just threw at you. So what is Docker? Anybody can get Docker right now. Install Docker. Install Docker Engine. So Docker Engine, we just go to docs.docker.com or just docker.com. You can look through this on your own time. I don't want to read the documentation in front of you guys. You can get it on your machine. Now, once you have it, I would also recommend, I like using the GUIs for stuff. You can get something called Docker Desktop. And let me show you what this actually is, and I'll show you an example of some Dockerization that I've written. So there's really three things that we need to take into account here. There are containers, there are images, and there are volumes. Now, an image is simple. An image, let me actually show you what an image will look like. Search images to run. So you just click on images, and we can find here, looks like I was looking for Postgres recently. We can find a bunch of popular pieces of software. Nginx, it's a very common proxy router type of situation. It helps route traffic around your application. Postgres, we've talked about Postgres. Let's look for Ubuntu, just a version of Linux. At the top, 1 billion downloads. I don't know, MySQL, I would guess 1 billion downloads. 1 billion downloads. I'm not exaggerating when I say that this technology is everywhere. It radically changed how applications are built and deployed. So when we have an image of something, essentially what you can think of that as a snapshot of some code or of some software that represents what that software does. An image, for all intents and purposes, can be recreated and then run, and it will run the same everywhere, everywhere. When you run an image, you run it in a container. A container is essentially that virtual machine. So you have a container running an image, and if I make a container, and if Amanda makes a container, and if anybody makes a container and runs the Ubuntu image, we're all getting the same thing. So that means that we have to, 1, have some code we've written ourselves. 2, we have to turn this into a Docker image. 3, we need to run this Docker image. And 4, we should be doing this on AWS or Google Cloud. And then 5, we have a domain name that we associate with whatever server or servers we're using on the cloud. I know that's a lot. Does anybody have any questions before we get into it? Yeah?
Wait, so when you say image, like it's not like...
It's not like a picture. It's a bunch of hashes. It's like a bunch of random strings. Basically, it's a representation you can think of what the actual software looks like. I can show you an example that might help. So I had this open. Let me see. So I have actually, and I will make a slide deck for this lecture after. I have an example on my GitHub here. Here's what's going on this particular repo. This code doesn't really do anything. It's just like a welcome to whatever. But we have a backend that's hooked up to a database, that's hooked up to a second database used for authentication. We have a front end, which is just your React whatever. And we have like a database manager system. So that the way I count it here, we have 5 separate things that are happening. 2 databases, a front end, a back end, and I forgot the 5th one. Anyway, so if we go into the back end, which is going to look like just a normalized project for us, you know, we got node modules, we got source, we got some stuff going on in here, our index.ts, like we've seen these before. This is just the application. It's just not very interesting. We have this thing called a Docker file. Now this is what makes the image for us. We run this Docker file and it will build the image. And what that just means is like, do you know how you have, when you download a program, you can download a GitHub and you can build it yourself, or you can just download like the .exe, right? And 99% of the time, most people are using the .exes. This isn't exactly analogous. An image is essentially an exe of the code. I don't tell that to an interviewer, but it's You can't see it, it's a bunch of ones and zeros. But here's how we get the image, is this code that's up right here. So what this is basically just some instructions from Node 16 Alpine. This is just saying we're going to build this using Node, right? Node's what we've been using. We're going to set an environment variable. Has any instructor thus yet talked about environment variables? Great, we're doing it. An environment variable is simply a variable that changes on your environment. I know that sounds sort of reductive, but for example, one environment variable might be NodeEnv. NodeEnv is, are we running in production? Are we running in test? Are we running in development? And based off of what this variable is set to, the project will behave differently. The project builds faster when it's in development. When it's in production, it's a little bit more secure, but it'll take longer to build. So this is just saying set that environment variable to production. Workdir is basically where this should be in the Docker container. Not important for now. You can just copy and paste rip this. Yarn, I use yarn instead of npm. Just pretend that says npm. It's the same thing. I'm copying all of the files over into Docker. I am building all the files that just npm build. And expose 4000. So we always have to go to port 4000 or 3000 or whatever, right? So this is just saying, when you run this in this container, when people try to access it at port 4000, give them the exe, so to speak. And then this is just my command, node. It's like I'm running node dis/index.js. Well, that's how we run projects. So basically it's saying, once this container is started, run that command. So it'll run the software in that container. They access that container on port 4000. It's a little bit roundabout way of making the code, but there is a reason why the entire world has switched over to this. Trying to debug, I don't know why it isn't working on that machine. Impossible. So this will make an image for us. I actually can't, I might be able to make one. I can't make it on my machine because my machine is literally out of memory. I'm going to make it on Amazon for us, okay? I'm going to invoice read like 3 cents for the server costs. So we have one for the back end. We have one over here at the front end. Another Docker file. And this looks pretty similar. The front end has to be built a little bit differently than the back end. You'll see a couple different environment variables. That's about it. And so right, our front end is on port 3000 typically we put it for React. So this is just saying you go to port 3000, go to the React. I want to actually put one on the internet real quick. So let's walk through that. Does anybody else have any more questions before I just jump into AWS? Hopefully it will be more clear when we can see this in action. So if I want to, for example, if I want to run an image just locally, here's 2 that I built, I don't know, 20 minutes ago, 2 hours ago. That sounds more than I thought. So I can just start this image. And it immediately exited for reasons beyond what I want to talk about now. It says I didn't tell it to do anything. If I say started, it'll say, oh, I don't have any more instructions. I'm going to stop. We don't need to talk about why that we need to avoid that. So let's go to AWS. So I've logged in on the account of one of my projects. The first thing I want to do is I want to make a server on AWS. So this is what this is going to look like. You get to AWS, you get to console home. EC2 is just their basic ass server. They have 7 zillion services. If you know about EC2s, that's like 70% of it right there. So I'm going to click on EC2. Let me just launch a new EC2. And that's sort of the advantage of the cloud is you can just launch. If I wanted to right now, they would let me launch probably, I think the limit is like 50 big servers, just me. If I was a company, I could launch 10,000 probably. So let's call this devs. So I want to run this on Linux. Ubuntu is usually how I run mine, just personal preference. You can run it on any type of operating system you want.
What is that? Like when you choose what operating system you run on, what does that mean?
So you're running on Mac OS, right?
Yeah.
So your computer has a keyboard. It's got a screen. It shows graphics. When I tunnel into this server, all I'm going to get is a command line. That command line will be running in a Linux environment. I could make it be running in a Mac OS environment if I wanted to. Most people, most of the time, are doing Linux or sometimes Windows.
So if you ran in a Mac OS, what would that then be? Like, what would be the difference if it's just a command line?
Well, the Mac command line is going to work differently than the Linux command line for one. It's very slightly different, but not a lot entirely. But ultimately, the operating systems handle stuff differently. Like the schedulers are different. I don't want to turn this into an operating systems class, but Mac, for the most part, is approachable and good for dev because it's essentially a nice fancy wrapper wrapped around a Unix operating system. So it's pretty close. Linux is free, Mac OS isn't. We're doing Linux. This is coming out of my pocket. So let's take a look. There's this T2 Micro. That's like the smallest one, or the second smallest, I think. Great. Key pair. That's just how we access this. This has to be secure, so I'm going to create a new key pair. This is a key. This doesn't matter. I'm just going to use .pem. Create a new key pair. So that's going to be in my downloads file, right? I'm going to allow traffic from anywhere for now. Typically, when you're setting this up yourself, you'll have to think about it. And I'm just going to launch one. I'm going to launch this bad boy. So this is going to take about a minute or so. Something that's really cool about cloud services is that, like for your project or for my project or for like a Hoya Devs project, you need a server. If you're at Instagram, you don't need a server. You need to make your servers increase or scale out as demand increases or scale back in as demand decreases. So doing things like Docker, where all you're doing is saying you have some automatic script running that says, if there's a bunch of people waiting to access our website and it's taking a long time, just spin up some more servers, run the Docker containers, do this all automatically. Yeah, it's very useful. So this is my server. It says it's still pending. It should be running by now, probably. Let me take a look. Yep, there we go. Let's connect to it. So I'm going to check it. I'm going to click connect. It's going to walk me through. I just follow the steps every single time. So the most important thing is that we are in the same directory that key is in. We have to be in the directory that the key is in, otherwise it's not going to think the key's there. It's not going to work. So I think I put that in downloads. Cool, it's there. So it's wanting me to run this command. Great, just makes the key usable. And then it wants me to do this to connect. So I'm going to SSH in. I actually don't know if all the professors make you do it. But if you guys ever SSH'd into like the CS class server, that's exactly what we're doing here. Exactly the same thing. Do you want to continue connecting? Yeah. Cool. We are now on a server in Virginia. Is where US East is for Amazon. So that's it. We're on some Ubuntu instance. That's the IP address, or that's the private IP address, excuse me. So let's get Docker on this thing. This is not something I know how to do off the top of my head. Probably nobody really does. I just look at the docs. So I'm going to copy paste a bunch of stuff here. Sudo apt update. Great. This is just going to update our packages. This is going to take a minute or two, so if you guys want to just shoot some questions out, otherwise I'm going to be walking through some boring documentation. Yeah, what's up?
So when you like host a website like this, like what are you paying for? Anything?
Oh yeah, I'm paying. So right now we're paying for an EC2 spot instance, which is just spin one up for me. I'll use it for as long as I use it, and I pay by the second. Now it's very cheap. I have an EC2 instance running that of the same exact type as this one that I just started that costs me, I think, $11 a month. Not bad.
And what does that let you do?
That lets me host, here, the one that's hosting specifically, oh shit. Oh, nope, we're good. Stop. One sec. I have it saved. That's a website I made to study Spanish note cards. So I can just access it from, it's just a website. So that server is serving my Dockerized code via Kubernetes, which I'm not going to talk about, way too complicated. That means anybody in the world can access this website with a shitty UI.
So you're basically just paying to keep the server up?
And serve the code. Yeah, I could do other stuff. I could be studying machine learning algorithms, you know? It could be anything. I could be using it as a database. It doesn't matter. It's just a workhorse server that it's a computer, you know? I'm paying for their compute power.
So when you host a website, you pay for the server and then like you buy a domain, that's pretty much?
That's a very bare bones way of like a very simple application. You rent a domain name, you essentially rent a server. Now, there are ways to get those permanently, not worth talking about. So, let's take a look. Sorry, I lost where I was. Do I want to continue? Yeah. So we're literally just getting Docker right now. A lot of this is just really obtuse looking shell scripts. Cool. It says I've seen output like I needed. I'm going to install Docker now. Yes, yes. So Amazon has a server that they're just letting me put stuff on. I'm installing stuff on their server right now. Yeah. And the three big ones are going to be Amazon, AWS, Google Cloud, and Azure, which is growing pretty fast. The thing is, they all have these great free trials, and it sounds great and lets you use all this cool stuff, and then you use it for a year, and then it goes away. It has happened to me firsthand. So just be careful about the free tier trap. What did I just install? Sudo apt install docker ce. Okay, so now this is going to check. Cool. We're Gucci. So we got Docker on here now. What does that mean? Well, let's get an image, let's build an image, and let's run the image. So I had the example repo that I just showed you. I tried to build that right before this class started, and it failed because something was out of date. So I found a random ass image that we're going to do instead. But before that, I was showing you guys just some of these common images, right? And volumes, by the way, volumes are going to be, think of it, a volume as just storage. It's a storage hard drive attached to your container. And multiple containers can access the same volume. We're not going to talk about that today. That's just so you know what the word means. So images, we had Postgres. So let's get the Postgres image. So if we go back to our, let me make this all small so it's easier for you guys to see. So if we go back, sudo docker pull Postgres, or let's do a run Postgres. Actually, you know what, Docker? Help. So this is going to show us all the commands that we can do. I always forget. So we can run a new container from an image. We can get into a command in the running container. So if we need to enter a terminal for this essentially mini computer that we have, we can go into a terminal inside our terminal. I know it's weird, but sometimes you need to access things directly to say like, kill this process or start this other thing or whatever. list containers, build from a Docker, pull from a registry. So there's a centralized repo, just like GitHub. There's a Docker hub, just basically a repository of all the images with billions of downloads. So like you can put your images for your project up there. And typically the way this works, like a pretty normal workflow for real world projects is you have a Git repository. Every time you make a pull request on domain and main gets updated, it will automatically trigger a process that builds the latest image of your whatever it is that you're building. And then typically what will happen is it'll go to Docker Hub. And then typically what happens is your servers that are running your code for your users will see that that was updated, grab the image from Docker Hub, bring it back down, and then start it up again. That's something that I've used this word Kubernetes before. That's something that Kubernetes will help with. But let's build some, let's build an image. So Docker build, I got to do sudo Postgres. I don't need to build, I want to run Postgres. So I'm just going to be running a database on their server. If this doesn't take too long, I don't think it should. Cool. So we can't see anything. It doesn't look like anything, but there's Postgres is running right now. So if I do Docker, I always got to do sudo Docker ps. So this is just list the containers. Oop. We can see, if I make this a little bit bigger, that there was a Postgres running 18 seconds ago that immediately exited. Again, it exited because I didn't tell it to do anything. It showed up, said my job here is done. I don't have any commands. Let me get out of here. But for 2 seconds, we ran Postgres on that Amazon server. And Postgres is there now. But we're talking about web applications today. So what we can do, and actually before I do that, I just want to show you a little bit, so you get a little bit of familiarity with the Docker command line. Docker-help. Basically, we can use it to list all our images. So sudo docker images. There's a Postgres there. We can do sudo docker ps lists all our containers. Right now, there's nothing running. Docker ps-a will list everything that has run. Typically, you're going to want to do ps-a. And then sudo docker kill will stop a container from running. We don't have anything up and running right now. We're going to kill something soon. Is this starting to click, or is this still completely obtuse and like in the middle? Okay. What I want to do is get an actual website running on this server. So I found one before class started. I wanted to build my own. I ran out of time. Where are we? None of these. So this guy had a website that's, to me, he's got a Docker file. And he's got a super simple app. This is in Python. We've been doing JavaScript. It doesn't matter. That's sort of the beauty of it. So I'm just looking at this. This looks like he's got a main route that says welcome. And then if you go to that route, it returns how are you. This is basically as bare bones of an app as you can get. So let me grab his app. So I can go to code. I'm just going to grab this repository link and clone it. So let me go back to my guy over here. So I'm going to git clone. So I'm going to get his repo. Cool. So I've got his repo. I'm going to cd into his repo. So now I'm in his code. So if we go back to what this would actually look like if we were looking at it as a GUI, it's got 2 things in it. It's got app.py, which is basically our index.js or TS, and a Docker file. Now this Docker file is going to look, actually this is almost exactly like mine that looks like, but it's in Python. So he's saying from Ubuntu, and this is actually the exact image that I'm running, which is really handy. I didn't even look at that. He's doing some updating for stuff. Flask is sort of like Express, but for Python. He's copying the files over to where they need to be, and then he's running this, and it looks like he's going to be running it on port 8080, which is important, because if we don't put this on the right port, we're not going to get anything done. So let's go back. to build this, we just have to build the image. So we go, we make sure we're at where the Docker file is. We are sudo docker build. And this is just, we're saying that the dot is just that we're in the same directory as the Docker file. I hope I didn't fuck this up. Cool, and I hope that this works. So right now we can see it running all these commands. He had 4 things on his app. 1, 2, 3, 4, or sorry, 1, 2, 3, 4. The from doesn't count. So we'll check the build. Typically, the actual run is going to take the longest. Or sorry, the actual npm build is going to take the longest. Looks like his run's taking the longest because it's downloading Python and stuff for us. And while that cooks, I'm just going to show you guys Docker Hub real quick. I was building images to put on the repo so I could show them how we just get it from Docker Hub. And typically, you don't want to build it on the actual machine that's expensive. You'll build it on your local machine. You'll put the images on Docker Hub, and then you'll just pull them down from Docker Hub. We're building on this machine. It could fail because this is like a super unpowerful server. But like I said, I ran out of space, so I couldn't build images on my machine. Cool. And I'm seeing all blue text, so that sounds like it worked to me. Let's run this image, okay? Docker images, sudo. Cool. So we got a new image on there. No repository, no tag, but it's got an image ID, which is good enough for us. So sudo docker run, and we have to expose the port here real quick. I'm actually going to check real quick. So I don't want to make sure that I missed. Nope, that's not it. I think, okay. I'm just going to go from memory. Hope for the best. Sudo docker run image. I'm going to give it some flags here. I have to make sure that I'm running it on port 8080, and that's the command line that I'm not 100% on. There it is. So the D means run it in detached. It just means let this terminal do other stuff. IT, I don't remember off the top of my head, but I always put it, and I don't remember why, but I think it's important. And this port just means what port are we on? Well, when we checked out this guy's application, we saw that he was running it on port 8080. That's his entry point into his application, is port 8080. So what we can do is we can say, when you go to port 8080 on the container, send it to port 88, or port 8080 on the container, send it to port 8080 on where his actual code is running. So I'm just going to make that the same. So port 8080 to 8080. That's what that means there. Fingers crossed, not confident. Cool. So this is running. We are now running this dude's application on our server on Amazon. I'm going to let this cook. Let's go to Amazon and see if we can make it work. So if you check out the EC2, we'll see that there's some stuff going on. We see instances. This is the public IPv4 address. Shot in the dark, if I go to this address right now, you can come teach this class if you guess right. What will we see if I go to this address? Any guesses? So we will see nothing. We are only exposing port 8080. If we go to this, so this is something that's important when we're talking about applications. An IP address is just the 4 numbers. Sometimes it's 6, it's usually 4. But there's like 65,000 ports for an IP address. Each port is doing something different. There's the HTTP port, HTTPS port, there's the SSH port, which is how I access the server in the first place. We want to run this on port 8080. So if we go to this right now, it's not doing anything on that. So if I go to 8080, it's also not going to say anything, but it's because I haven't set one more thing up yet. Site can't be reached. Thought so. But we see now it's spinning. Before it wasn't spinning. Why is that the case? Network policies. So when you set up a server, there's always going to be things that we have to take care of related to security. Anyone here seen a firewall table before? We just have to set up our firewall table. I did mention this lecture was going to be very different, right? This is just a complete right turn. But let's take a look at our security rules. And honestly, I imagine, I've never done it, I imagine this is something ChatGPT would be able to help with. So we go to our security group, edit inbound rules. So what's happening here? It's blocking our network request from an outbound, whatever IP address I'm from, it's blocking it. So what we want to do is we want to allow a rule to allow that to just access 8080. So I'm going to add a rule. I can do custom TCP. For now, I'm going to do all TCP traffic. It's just a type of network traffic. On all ports from any address, so that's at 00000, should be allowed. If I save that rule, deployment's hard. I hope I didn't mess anything up. Let's take a look. Okay, so now it let me go to it, but it's not actually showing anything. So we do see that it's not blocked anymore. So I will take that as a huge win. Let me check back at what's going on with this guy. So when it says it's running on HTTP 127.0.0.1, well, that's our local host, right? So the local host for this address is whatever its public-facing IP address is. What it thinks is localhost, we know to be this IP address. It says it's running, so we should be good there. I'm going to open this address again. I'm probably doing something dumb, and hopefully we'll be able to figure it out relatively quickly. Let me try to curl it real quick. Nope. Could not connect. Sorry, bear with me. If you want to ask questions, just jump in. I'm going to troubleshoot for 2 seconds.
I have a question.
Yeah.
So say like, you write your code and then you host it like this and you like want to update it. What's like the process for like putting your new edited code up on the website? For
sure. So the old way before Docker was you manually go in, you reclone the repo, you run it again, you hope everything works. Once Docker got introduced, everything sort of changed. So there's something called CI/CD, which stands for continuous integration, continuous delivery. And the entire point of this process is to make sure that your code is built in a sustainable, automated way, and make sure that your code is deployed, the continuous deployment, in a sustainable way. Now, there's a lot of different ways that you can do this, but typically the CI part is like, make sure that you've encountered a professor with Autolab. Basically, with CI, you make sure that your code passes all the tests, like Autolab. that it builds correctly, does all sorts of stuff. If it passes everything that it should, and you can make this pretty complicated, then what you can do is you can start triggering some scripts, like build a Docker image of it automatically, then automatically send that Docker image to my server, then automatically make a container of that Docker image, and then once that new Docker image is up with a new container, then automatically take down the old container. If you do it right, users never know what happened. Places like Google are constantly up, like YouTube, I probably got updated 10 times today. And because this is all automated, we never know.
So like if you write all these scripts and stuff, you could basically edit your code, save it, and then it would automatically update.
If your code builds correctly and passes all the tests, that is what the field is called DevOps. That is what DevOps is basically automate away all of this shit that we're doing today. Just make it all automatic. Because nobody wants to do this. It's a hassle. Let me see. Let me actually I'm gonna look at something else. I might have messed up a security rule. I'm actually going to change this. I had it set to accept everything. I don't think that would be the issue, but let's do a custom TCP. And port 8080. Source, custom, sure. I don't think this will change it, but it can't hurt to check. Nope. 4 permission entries, 1 permission out tree. Oh, hey, people are using my website that aren't me. I legitimately did not think that would be the case ever. Let me see. I don't want to keep you guys here while if I can't get this in 3 minutes, we're going to call it. But port 80, 4000 TCP, protocol security rule. 1000 TCP. Also, don't think this will do it. I may have run the Docker image incorrectly, so let me take a look at that. Oh, it's going to be one of these. So I did not run this in detached mode. I mentioned we should run it in detached mode so that this doesn't happen. Clearly, I did not pass in the right flag, so we're going to have to do one of these. Connect.
On the documentation, it said a lot of the flags are in front of the image.
I don't think it should matter, but I can try it. It may be it. So I'm just SSHing it on another port here. So it was ls sudo docker. So we can see here the image is still there. Sudo docker ps-a. It's still running. We can see it was created 10 minutes ago. So I'm going to kill that. So we see no images are running. So I wanted to do sudo docker run -it-p map to 8080. And then the image name was this guy. Okay, well, it behaved differently. Let's take a look. Let's go. Yeah, I messed up the command line. So we have a website on the internet now. That's pretty exciting stuff. I know that there's not a lot going on with this internet or with this website. It says welcome. It's as simple as possible. This could be the biggest, grandest React app you've ever seen in your entire life, and it would work the exact same. It doesn't matter if it's got 7 million dependencies. It doesn't matter if we've got 4 million lines of code. It's just going to work the same exact way. It's just a simple welcome. This is the advantage. So just to walk us through one more time, we have on Amazon, we made an EC2. We connected to the EC2 via our terminal. Once we were on the EC2, we put Docker on this EC2. We then, in this case, we built the image directly on there. Typically what we would be doing is downloading the image from Docker Hub or from wherever our company stores our images. At that point, we ran the image using the Docker command line. Typically Google or ChatGPT or just docker -- help can help with this. And then we configured our firewall rules on Amazon in order to be able to let us actually access that port. Now, there's 2 more steps here, maybe 3. What is wrong with this website, aside from the fact that it's just a single line of text? So what's up? Yeah, that's just well beyond the scope of this class. It is not secure. We're not going to make it secure. That's too much work. Aside from the fact that this is not secure, what else is going on? Well, that's because of the not secureness. If this was a brand new website that I made and I want to sell Collins widgets and I tell you about it, I say, oh yeah, it's real easy. You just go to 3.86.24.59 port 8080. It's a nightmare, right? So this is why domain names exist. So if we get a domain name, what we do is on Amazon, so this is just going to work differently for every cloud provider. On Amazon, we go to something called Route 53. And this is just hosting our domain names. So there's going to be tutorials for this. I don't want to walk you through it. Let's say that, and typically you have to set this up both on GoDaddy, which I would recommend never using for any reason, or a GoDaddy equivalent. So you set up, basically you tell GoDaddy where this server is, and you tell this server where GoDaddy are. Typically it takes about 2 hours for them to be able to talk to each other, and then you're chilling. So now we can go to, hypothetically, we would be going to collinswidgets.com:8080. Still not great. Just to do a little bit better, we would have to use something called Nginx, which is a reverse proxy, which sounds really hard and scary. All that is it's just saying, hey, when someone goes to collinswidgets.com, let that stay in the search bar, but actually send them to collinswidgets.com port 8080. And you can do that with like 2 lines. The cool thing about Nginx, it's a Docker image. If I check out my Docker desktop, I guarantee Nginx is probably the top one. Maybe Postgres, maybe Ubuntu. I was just signed in 2 minutes ago. Whatever. Okay, cool. Hub. It's going to fight me. But anyway, basically you get your Nginx set up. And then once you have that set up, all of this, oh, my database is on port 5432 and my my backend's on port 4000 and my front end's on port 3000. You just route it together. I am going to call it a little bit early. The one thing that I will mention about today's lecture is this is not going to matter for the rest of your time in undergrad in terms of your classes. This is probably not going to matter for Hoya devs too much. This will matter for your internships. Anybody here know Matt Jordan? He's part of the Hoya devs leadership. He just got an internship specifically about this shit, about Docker and Kubernetes. It pays incredibly well. It's super relevant, and it will, like every job application is like, hey, we want you to know Kubernetes, and if you don't, good luck. Again, this is important stuff, just not for now. Hopefully in a year or so, you'll think back and remember this lecture. Cool. With that, I'm going to turn my recording off.